recorded video after this, insyaAllah. Usually in the morning, if we have this session in the morning, sepatutnya traffic tu kurang sikit lah kan, internet. So Alhamdulillah, we still in the morning, belum lagi sampai tengah hari. So Alhamdulillah again and again, insyaAllah, everyone managed to submit their quiz for this chapter before our class today. So enabling us to actually review or discuss. Walaupun sebenarnya boleh je you access your question and do some editing before the actual submission deadline. Sebab dia, I'm not sure you guys aware ke tak, you can actually attempt the questions, tapi tiba-tiba kan bila tengah buat tu tiba-tiba adik kacau lah, tiba-tiba your mom minta tolong ke apa kan, you can actually click submit first and then do it in another time. Maknanya you tak perlu kena bila start tu terus habiskan complete in 1 hour. Tak juga semestinya. I'm not sure whether you are aware or not lah. Tapi it's better kalau you boleh sekaligus kan, supaya you can still adhere with the time constraint that you need to oppose on yourself. Tapi yelah, kita mengiktiraf lah, kadang-kadang ada setengah orang tu akan ada challenges untuk nak complete everything in 1 hour. Distraction kiri kanan kan. Lagi-lagi kalau ni lah, kalau kita tengah buat test tu, tiba-tiba adik ke ataupun parents ke atau other siblings ke tengah tengok TV lah kan, tengah tengok TV, tengok movie lah segitu kan, distracted. So slow lah habis. Tapi nak cerita, you have that option lah. So although the deadline set midnight tonight, but I did mention last week kan, kalau kita berjaya siapkan before 10 o'clock, before 11 o'clock, we can actually do the review today, so that senanglah hati, esok boleh terus start chapter baru. And Alhamdulillah all 18 of you managed to do that, so you can give yourself a round of applause. InsyaAllah. So we'll proceed with the review lah. So how did you find the quiz? Is it okay, mild?
Okay, moderate.
Moderate. Okay, let me just mindful lah sikit lah. How did you find the quiz on chapter 11? First option is, oh ya, susah gila. And kita add answer. Oh, okay lah. Kat senang. Tak ada soalan yang lebih. Okay. Contohnya kan, so you are talented kan. Alright. Okay, sambil-sambil lah, sambil-sambil kita buat review ni, you can answer the poll lah, insyaAllah. Okay, ada option untuk susah dan susah gila kan. Susah gila mungkin bukannya sebab you don't understand, dia ada external factor jugalah kan, environment and pressure, duduk rumah, and then boleh nak access untuk nak proper lecture, semua terhad dekat kecil ni. So tak apa, kita cuba yang terbaik insyaAllah. Okay. Alright, so siapa-siapa yang perasan, ada lagi seorang lah yang tak kan, apa, Danny kan. You can actually answer the poll so that I can know what are you thinking right now. Okay, so kita proceed lah
Okay.
MCQ, so this time round dia ada 10 questions, beza sikit dengan standard 5 questions yang you dapat kan. So just bagi masa lah untuk kita nak jawab MCQ ni lebih biasakan diri. So what are the carries solution during electrolysis? Tiba-tiba first question je dah masuk electrolysis kan. This was not in the material, this was not in the video, this was not in the notes, betul tak? Tapi you guys know what is electrolysis kan? Belajar buat test dulu kan?
Yep.
That means you have a circuit and then you dump it dekat dalam solution tu, so dia boleh jadi apa-apa solution. So usually orang akan guna sodium chloride lah kan. you dia punya circuit tu nanti dia akan pisahkan kan, the positive ions and the negative ions, they will be attracted to the respective cathode and anodes, which allow electricity to flow. Betul tak?
Yep.
Yeah.
Ni example lah kan, you got alright, and then at the end dia akan pecahkan lah kan, dia panggil apa, cations and anions. Oh, I didn't know that.
Anion.
Oh, the cathode ions and not ions. Oh, Masya Allah. Okay, and then dia emit hydrogen gas. Kenapa ada emission of hydrogen gas? Because of solution in water lah kan, hydrogen and oxygen so so nanti kita after a certain period kita akan tengok dekat the respective rock akan adalah dia punya sodium and chloride tu terpisah kan, betul? Alright. So the question is, what are the charge carriers in the solution during electrolysis?
Positive and negative ion.
Yeah, it must be positive and negative ions both. So soalan ni adalah charge carriers kan?
Yes.
That means apakah kita panggil apa, ions. That means the charge kita panggil apa, atoms, the atoms that carry charge, which is the ions. So they have both positive and negative, which is referring to sodium and chloride kalau dia ada sodium chloride solution. So the answer is D lah. Okay. Sampai yang ni tak adalah directly related to our material concerning the circuits, tapi dia masih lagi the concept of current of electricity kan. We can actually flow current without a complete circuit yang ada wire connecting the entire circuit, tapi as long as kita ada satu medium or a solution, then it's good enough. Okay, question number 1. Okay. Question number 2. There is a current of 0.24 amperes flowing through a lamp for 40 minutes. How much charge passes through the lamp? So dia 40 minit, kita buka lampu. Itu soalan dia kan. So we use the equation. Kita tahu the current is given as I equals to 0.24 amperes. Time is T equals to 40 minutes. So we just use the equation Q equals to IT. Yang ni sama equation yang kita guna waktu chapter 10 kan. Chapter 10 hari tu apa nama tajuk chapter 10, lupa dah. Apa?
Electric fields.
The electric fields lah kan. Okay, thank you. Je buat-buat tak tahu nak tengok. Siapa yang boleh. So electric fields, dia ada charge, dia ada Q, so dia main dengan current, masuk juga kat sini. Okay. So kita just substitute, just make sure T equals to 40 minutes. We convert it into seconds. So masuk sini, so the answer is 576 columns. Jawapan dia ialah A. So siapa yang ada jawapan dekat atas kertas buku tu, boleh siap-siap buka lah kita naklah sekadar nak tahu jawapan kan, TA semua kan, tapi lebih daripada kita nak tahu the concept. So this is the reason why I make a point of doing this session with you guys. Sebab kalau kita buat lecture saja, kita tak practice soalan tu, susah sikit lah kan. So we kill a few birds with one stone lah kan. You have to do the quiz. So you actually want to know how you fared during the after the quiz kan. So but still kalau ada silap, mestilah you nak tahu apa yang silap kan. And then kita boleh discuss sama-sama. So we discuss the questions and at the same time we try to discuss the concepts and theories behind the questions, so that boleh sekali lah ikutlah kan. Lebih-lebih lagi, most of the materials discussed in the syllabus for AS, kebanyakannya you dah belajar waktu SPM. So dia macam repetition saja kan. Okay. So this is it. Question A, right? Sorry, question 2. Answer is A. Question 3. When a resistor is connected across a battery of 2.8 volts, there is a current of 0.35 amperes. What is the resistance of the resistor? Straightforward. O, potential difference atau kita panggil voltage, B equals to 2.8 volts. I equals to 0.35 amperes. So it's not in milliamperes and whatnot. So kita boleh directly calculate the resistance using the equation V equals to IR. Where we rearrange the equation in order to get R equals to V over I. So the answer is 8 amperes. Straight away, the answer is A. So can anyone comment on the number of decimal places here?
Okay.
It's supposed to have 0.1 decimal place.
Katanya dia kena ada two significant figures.
Significant figures.
Sini figure.
Is two significant figures, 0.35 is two significant figures. So it should be 8.0. Tapi jawapan yang dia bagi 8.00. Ha. Macam mana? Dispute tak soalan ni? You are not consistent with what you teach lah kan? Cik. Tapi yang ni salah pasir, you nak buat macam mana kan? Hari tu you kata you kena ambil yang list. Tapi kenapa you buat dua? Lepas tu dia pun cakap balik kan, alam, you pun biasa juga kan bagi extra significant figures kan dalam you punya calculation kan. So jangan nak marah-marah. So the answer is 8 ohms. Alright. Okay, question number 4. Everybody doing alright?
Yes.
Yes.
A car headlamp. Car headlamp. Boom. Okay, ni bukan yang transformer This is just a random image that I Google Okay, a car headlamp when a volt battery converts energy at a rate of 50 watts. How much energy is converted when it is switched on for 5 minutes? So, ni soalan ni macam mana? Best tak soalan ni?
Straightforward.
soalan ni jawapan salah kan? Tak ada jawapan kan?
Is D.
Betul tak? I think
Lebih 1-0.
two groups yang saya moderate lah Out of the two groups, ada seorang yang tanya, lagi seorang pun tanya. Seorang daripada group ni, lagi seorang daripada group lagi satu. So saya pun imagine, oh, you all hantar wakil kan macam you all ada separate group.
Oh.
Yes.
Selalu macam tu kan, you guys ada group yang tak ada lecturer kan, jadi group sama you all saja kan, so macam boleh discuss jawapan apa. Tapi tak kot, you guys saya tak macam tu kot. Okay, so how do you answer this? So there are actually values yang kita tak guna langsung kan, betul tak, dalam dia punya soalan ni.
Yeah.
We are given the potential difference, the voltage V equals to 12 volts. Rate of energy is equal to E over T. Rate of energy which is actually equivalent to power, 50 watts. So the time is 5 minutes. So the question is asking how much energy is converted when it is switched on for 5 minutes. So sebenarnya kita tak guna pun potential difference. So kita tak kisah pasal bateri sebab kita dah tahu power dia apa. Tapi kita kalau tahu current tu cerita lain lah kan. Tapi kita dah tahu kat sini energy equals to PT. So convert T to seconds. So we'll get the energy is equal to 15,000 joules. So the answer, tak ada answer kat sini. So tapi jawapan dia lagi ada typo kat sini.
Hey.
Tapi I'm not sure kalau kita tengok nampak screen? Ish, bahaya ni. So this is your overall mark lah kan? Ish, kalau tengok bawah ni mati kantoi ni. Laju. Ni adalah mostly you guys A-state lah, tapi adalah yang mungkin careless mistake kan. So yang ni tadi question apa? Question 4 kan?
Yes.
Ironik dia. So jawapan dia salah tapi semua orang dapat betul. Ada macam interesting ni, boleh buat research ni. Masalah kan, tapi everybody got it right. My god, Masya Allah, memang amazing lah. Soalan
Answer yang paling dekat je.
answer yang paling dekat kan. Okay, alright. Okay. Mungkin sebab yelah nampak sangat yang beza kan. The rest is 120, 300 and this one is 150,000. So macam agak obvious jugalah kan. Kita proceed Alright, question number 5. A current of 2 amperes passes through a component of resistance 24 ohms. what is the rate of transfer, energy transfer. So yang ni nampak macam straightforward, you just have to derive. If you do not want to memorize the pi formula, which I strongly advise not to memorize, but know how to derive. You just have to remember two formulas, isn't it? P equals to VI and V equals to IR, and then you play around. So here you are given the current, you are given the resistance. We need to know what is the energy transfer. So energy transfer, energy rate. So dia bukannya minta energy ya, dia minta a rate of energy. Okay, not to be confused lah. Tapi rasanya sebab yang ni MCQ. Sebab memang dia nak dalam words kan. So mungkin tak confused lah kan. Rate of energy, in other words, they are asking what is the power transfer. So P equals to VI, you substitute V because we are not given the voltage. V equals to IR is going to be equals to I squared R. Substitute the values, you have no problems with the amperes in milliamperes ke tak. So just ambil value tu sendiri, you get the value as 96 watts. Kalau siapa yang careless tu mungkin I'm not sure how you can get careless lah. Mungkin kalau you terus darab and you dapat 48 mungkin. 2 darab 24 and you forgot to square. Probably that's why some of you answered C ke mungkin. Wallahualam. Okay. Alright, so the answer is D. Moving on, question 6. What is the unit of resistivity? Kita tengok sikit apa kata survey. So ada dua yang careless, probably. Mungkin sebab dia terbaca salah. It should be resistivity, not resistance. Tengok, yang salah tu dia jawab apa? Yang salah jawab D. That is interesting. Sebab kalau D is ohm per meter squared. Kalau orang yang tersilap resistance mungkin ohm lah kan. But the answer of course is ohm meter. So I'm not sure why you guys answered ohm. That's interesting.
Oh.
Because I would believe yang careless tu dia, what's the unit of resistance? Ohm kan. Tapi ni ohm per meter squared. So probably tu tak boleh nak tolong kan. Because units of resistance is R. For R is ohms. Units for resistivity is the symbol is rho is equals to rho m. How do you get this formula for rho m? Go to the notes. Okay.
Yeah, that one.
These are the notes. So dia sebenarnya sama RA over L kan. So kalau RA over L, if you have RA over L, R is ohms,
Square
A is meter squared,
Meter square.
over M.
L is M.
Yeah.
So kat sini indirectly, so the answer is just meter lah. Betul lah.
Yeah.
Apa saya cantik-cantik ni?
Yes.
Alright, good job. Okay, so that's it. Question number 6. So resistivity. This concept of resistivity will be used nanti waktu subjective question kan. Alright, moving on. Any questions so far?
No.
Right, question number 7. Alright, this is interesting. Kita akan ambil masa trying to discuss this one. Which of the graphs shows, although the question is asking straightforward lah, cumanya I want you to comment, let's discuss together. Which of the graphs shows the IV characteristic of an ohmic conductor? So okay, putting that aside, putting the question aside, because apparently all of the four graphs are valid, maknanya dia bukan graphs lah kan. So can I have somebody explaining to me for graph A, dia apa? Nak volunteer basis ke ataupun nak pick and choose? Nak volunteer ke nak pick and choose? Saya buat poll lah, kita main poll lah boleh tak? Sekarang ni semua segan-segan lah kan, kita main poll. Okay, open new poll. Okay, nak saya pilih siapa kena jawab atau volunteer? Give answers. Sepilih. Sekejap aja, sorry. Lepas tu volunteer lah ataupun tak nak jawab boleh. Boleh. Okay, dia slow sikit. Memang Webex ni is very heavy. Petai pun kadang-kadang itulah. Tapi this is the best yang boleh buat. Okay, silakan. 17 of you saja. Ada orang terkeluar.
7.
Oh, nasib baik. Tadi ada yang jawab tak nak jawab kan. So you guys are good students. Alhamdulillah. Ini bagus juga kan. Jawab. Tinggal satu lagi. Dia juga orang tak nak jawab. Okay, dia 50-50 lah Okay. So for those who volunteered first, I invite siapa-siapa yang nak volunteer tu untuk jawab dulu. So I'll give you the ability to annotate. So my question is, describe to us this graph. Maknanya bukannya nak bagi tahu graf ni represent material apa, tapi lebih kepada menceritakan and then you conclude this graph is actually representing what. Okay. Siapa daripada 7 yang volunteer tadi? Anyone? Don't waste time.
Azmi.
Siapa yang volunteer tadi? Siapa yang nak volunteer? Ada 7 orang yang kata nak volunteer. So I give you the chance lah untuk nak volunteer. Silakan.
Saya
So, you guys are wasting valuable data now. Ada 7 orang. Hello.
Please.
Volunteer bukannya.
Sir, saya.
Okay, ya sila.
Sebab saya ingatkan saya tekan volunteer tu macam orang lain kau volunteer, saya tak nak.
Okay, silakan.
So, the graph is not linear.
Okay.
Itu yang pasti.
Yes.
Okay, I don't know what else to say already.
That actually applies for the other 3 options, A, B, and C. The graph is not linear.
Itu.
For the A, is it an amplifier graph?
Amplifier graph? What do you mean by amplifier graph?
Is it a filament?
Is it tungsten?
It's a filament lamp, kan?
Filament lamp.
Okay, like I said just now, before concluding what type of material are we talking about, please describe to us the characteristics first. Maksud dia, trend dia, comment on it. Like with increased potential difference, what happens to the current, probably has got something to do with the temperature.
Everybody can hear me,
Yes.
Yes.
For that graph, when the potential difference, do I have to talk about the negative part of it?
Okay, because you in the notes you are actually given only the positive part, betul tak?
Yes.
Ya, so, tapi sebenarnya dia mirror saja, negatif pun lebih kurang sama saja. Although macam negatif tu sebenarnya dia tengah signify different in direction, bukannya magnitude. Okay, silakan.
So since the graph is not linear, so when the potential difference increases a bit, but the current, the change in current, dia increase lagi banyak daripada tu. So that's why it's not linear, so dia macam naik sikit. So when dua-dua naik, macam the potential difference increase, the current increase, that means the resistance is low. Yeah.
Macam acceleration.
It can only mean that, okay, it can mean anything sebenarnya, but so the appliance, the component is a thermistor when the temperature is high. Yes.
Sorry, I lost you when the temperature is high and then?
I stopped there.
Okay, you stop there. So when the temperature is high, that means maknanya apa? Because of lower resistance, the temperature is high. Ke?
So the temperature is, when the temperature is high, it gives this graph for a thermistor.
Saya rasa macam ada dengar belik-belik buku tu. Serap. Tengok nota
Tak, saya tak buka buku pun.
Okay. Thank you very much. Okay, thank you very much. Okay. Round of applause ni. Alhamdulillah. So kalau kita tengok dia punya graph kat sini kan. This is the graph, of course. So for an IV graph, dia punya gradient represent what?
Resistance.
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 One over resistance.
Thank you very much. Siapa yang jawab? One
Oh.
yourself a clap.
1 hour resistance.
IV and API.
But it is the inverse of the resistance. Sebab tu tadi bila your friend said with increase current, potential difference tu increase juga. Cuma current tu dia increase rapidly, lebih cepat kan. So the gradient actually increases, but because of increase in gradient, the resistance decrease. Okay, so this is a good example of a thermistor. Tapi thermistor ni dia bergerak macam mana? Dia bukannya disebabkan resistance dia berkurang, maknanya temperature dia menaik. Tak. It is actually the other way around. Because a thermistor, the temperature, the thermistor is actually a sensing device that senses temperature. So what it does is, bila dia detect an increase in temperature, because this is what we call a negative thermal punya resistor, bila increase in temperature, dia punya resistance akan berkurang, as opposed to a filament lamp. Filament lamp yang mana satu? A, B, C or D?
C.
Jadi kita A
C.
thermistor, betul?
Yes.
Sure.
B thermistor.
Kan?
Huh?
B is diode.
B is diode.
B diode.
Kat
C
A.
is filament.
Tak buka nota lah kan? Sebab nota dalam phone
B
kan?
is ohmic.
Semua tak boleh lah. Salah constant ni kan? Tapi ada yang print out. Dalam juga ada yang you guys print out kan? Okay, anyway. So, maknanya kalau thermistor, dia detect temperature. So difference in temperature will cause a difference in its resistance tau. Cuma yang temperature ni, thermistor ni dia berbeza, dia directly opposite dengan filament lamp. Kalau filament lamp, increase in temperature would cause an increase in resistance. Tapi kalau thermistor is the other way around. Kalau increase in temperature, dia akan decrease in resistance kat situ. Okay? So, kalau kita boleh concludekan between these four graph, A is actually a thermistor where it senses, okay, it senses temperature. With increased current, the temperature increases. The resistance will go down. The difference in current akan go up and up. So ini cara macam dia sense lah kan. Maknanya kalau kita ada satu circuit tu, we have a thermistor punya component, then it detects an external change in heat. So when the temperature increases, the resistance will decrease kat situ. Okay? So for B, yes, it is a semiconductor diode. So for a semiconductor diode, you have two situations kan. Kalau you boleh ingat balik you punya electronics lah. You've got the forward bias and the reverse bias. Apa beza forward bias and reverse bias? Forward bias, it conducts with rapid increase in I as V increases. That means dia akan allow current to flow. Tapi dia akan allow current to flow tu sama macam a standard copper wire. Tapi kalau dia reverse bias, dia akan ada banyak sangat resistance. So dia punya current will almost equal to zero. So can anyone welcome Sheikh to our class? Ke awak sebenarnya dah sampai awal dah? Saya pun baru perasan. Tak perasan. Tadi macam ada. Terus sekejap ada, sekejap tak ada.
Salam sir.
Okay. Can anyone draw me the symbol for a forward bias diode? Boleh draw kat mana-mana. Okay, draw. Volunteer lagi Kita ada 7 orang volunteer ni. Draw me the ni. Siapa yang dah volunteer? Volunteer lagi. Siapa yang nak volunteer? Siapa yang belum volunteer lagi? Please volunteer again. Tak ada dah volunteer kita tadi. Alright. Forward bias diode. We are waiting patiently, insyaAllah. Hopefully, the ni lah. Are you done? Ini yang tengah tulis ni siapa? Nurin ke Arif?
Arif.
Okay, Arif. So are you done?
Yes.
Okay. This is a very beautiful drawing, mashallah. Congratulations. But it does not represent either is a forward ataupun bias diode. We do not know whether this is a forward bias or reverse bias diode. How do we know whether it is a reverse bias diode?
The symbol.
Symbol negative, positive.
Positive, negative.
So where must be the positive and negative signs?
Positive must be at the long part.
Okay, please you can annotate. You can draw. Alright. Extra points. Siapa yang volunteer? Cik. So I guess this is Amir and Nurin Afika drawing together lah kan, betul tak?
Yes.
Ya, tapi bila tak ada habuan dunia ni semua tak nak buat. Tapi bila nampak habuan tu depan mata bukan main lagi kan. Yes. Anyway, that is human lah, biasalah. Okay. So forward bias, kalau forward bias maknanya positif negatif, current will be flowing through. Cuma karakteristik current tu dia tak adalah direct linear macam punya karakteristik. Tapi dia akan ada exponential increase kat situ. Cuma kalau reverse bias, lagilah dia tak akan allow any current to go through because of very high resistance. Alright, C is a filament lamp. So if you observe, dia punya filament lamp ni almost similar to thermistor, tapi dia opposite dekat bahagian resistor tu. When we have increase in temperature, resistance dia akan so implication dia ialah change in the current will be lower lah. Sebab dia punya gradient kita akan tengok dia punya gradient. So the answer is D. It is ohmic because I is directly proportional to V. Hence it has constant R. Given that we are at a constant temperature condition. Okay? Boleh?
Yes.
Okay, rehat sekejap. Kalau ada soalan boleh tanya. Nanti kita akan proceed to next question. Sambil itu nak borak-borak boleh, insyaAllah.
Sir,
Yes.
I have a question. If we left an electrical appliance for too long, can we have the resistance? So the
Sorry, can you repeat again?
if we have an electrical appliance and we leave it for too long, and the temperature of the electric appliance will be hot, right? Because of the resistance opposing the movement of electron, kan? So if the electrical appliance is actually a simple metal conductor, then will the graph of the current voltage graph will still be linear?
Will it be linear? So you are talking about a metal conductor, which is actually kita panggil apa? An ohmic conductor lah kan?
Yeah.
Conductor, characteristic supposed to be you said, tapi you keep it on for a long period
Yes, and it will get hot.
and it will get hot. Okay? The question is?
The question is, will the graph of the voltage, will the graph of current voltage will still be linear?
Okay, thank you very much. So the answer is it depends on the type of material ataupun you mentioned an electrical appliance. Sebab kalau ideal situation, it will keep on linear as long as it is in constant temperature, betul tak?
Yes.
Sebab it obeys the Ohm's law. Cumanya in actual condition, the graph not be linear because due to the increase in temperature. When the power is given for a long period of time, and then we have that condition. Bila temperature tu increase, kan? You charge phone you, silicon is it an ohmic punya conductor? You might check that again. You ada Samsung punya phone kan yang a few years back kan, yang Note 7 kan silap, ke Note 7 ke Note 8, yang dia charge sekejap lepas dia meletup kan.
Meletup.
So kalau ada tak pengguna Samsung kat sini,
Note 7.
that is a situation yang sepatutnya bila dia charge benda tu, tapi dia guna capacitor lah kan. So dia simpan charge. So that is the it is actually a similar condition lah. When you prolong the time period and the charge and the charges actually are kept inside within the electrical appliance and dia tak ada nowhere else to go kan. So bila dia ada nowhere else to go, so dia akan accumulate kat situ, so power tu dia akan increase, so kat situlah dia punya graph tu dia akan jadi exponential kat situ. Tapi that is a real condition lah, given temperature increases. Faham ke?
Yes, yeah. So it will behave like a filament graph, right, sir?
Yes. And but at the end of the day, it actually depends lah. But in your question, because you have already clearly stated the temperature increases, so we are looking only at your condition in which the temperature increases. And but actually it depends on the design of the appliances juga lah kan. Kalau dia guna inhibitor untuk nak elakkan charge tu terkumpul so that it can maintain its temperature, and usage of 3-pin and 2-pin pun membezakan kan. Kalau dia boleh earthkan all the charges in order to avoid accumulation of charge, hence the increase in temperature. Faham ke?
Yes, yes.
So only because the condition is temperature increases, so dia akan behave like filament lamp lah kat situ. Alright.
Alright, thank you, sir.
Okay. Proceed Question 8. So question 7, the answer is D lah Okay. Calculation. The diagram shows two wires, both made from alloy Eureka. Wire 1 has length L, diameter D, and resistance R. Wire 2 has length 2L and diameter 2D. What is the resistance of wire 2? So, I think we had like, 5 volunteers, still 2 volunteers left. Can anyone perform the calculations for us on this side of the slide? Boleh kan? You can, okay. You can request for anything, insyaAllah. Siapa yang nak jawab? Nak saya pilih?
Kita pilih.
Saya pilih lah ya. Dia macam slow sikit lah. Tapi kalau saya nak pilih ni dia kena orang yang guna phone boleh ke?
A bit hard kot.
Pihak lah kan cik. Tak guna phone eh. Sekejap lah siapa yang tak guna. Phone. Ini guna phone. Irfan or what Irfan?
Haha.
Boleh Irfan? I give you access straight away. Nah, you can note it.
What should I don't remember the question.
So what is the question? Can you show us the calculations in order to answer this question?
Okay. Wayu.
Okay, what you want? Nice handwriting by the way, Masya Allah.
Wait.
Are you using a mouse or your touchpad?
Using mouse.
Oh, Masya Allah. Saya tak boleh guna mouse ni. Memang kena guna touchpad. So what you want? R equals to L D over 2 squared. Good job. Because A equals to pi R squared lah kan?
Because the resistivity is constant in both wires, and pi are also constant.
How do you conclude that the resistivity is constant for both wires?
Because both are made from alloy Eureka here.
Because they are using the same material, yes. Okay.
Okay. So the resistivity is that is resistivity of wire 1.
Okay. So the resistance kan? Bukan resistivity.
Resistance, not resistivity.
Use the symbol R. Ni jenis yang tulis dekat working tu betul, tapi bila pergi dekat nak tulis type dekat answer punya tempat dekat Google Form tu salah kan? Saya saja joking. Pagi-pagi kacau-kacau. Monday blues. Apa benda ni?
2D over 2 for the area.
Okay.
So this is L over D only, because 2 divided by 2 becomes 1. Oh, sorry. Got the square.
You forgot the square. Okay.
Because the D is squared, it becomes D square.
Okay.
2 becomes 4.
Okay.
At here, 2 divided by 2, it cancels out, and D becomes D square.
Okay.
So R1, R2. This is supposed to be ratio, not equals to.
Okay.
So the ratio is 4 to 1. Wire 1 to wire 2.
So the answer is?
The answer A.
Oh, that's interesting. Semua agree ke dengan dia punya jawapan?
Saya jawab 2R. Oh wait. I think I saw my mistake.
How can you see your mistake?
Here, the 2 I forgot to write 2 here.
Okay. Okay.
So here
Saya
is
boleh
2.
notice your mistake ni. WhatsApp group ni ada orang tegur. Salah.
No. So the ratio is actually 2 to 1.
What? What's your answer then?
Answer is B.
B.
Semua agree ke?
I agree.
Yes, B.
Yes.
Ya, betul. So kat mana yang tersilap ni kat sini tak ada tu?
2. Lupa nak letak 2 dekat sini tadi.
Ni. Sedangkan you dah ini kan?
Dah letak lah.
Tapi bila transfer kat sini,
Lupa 2 tu.
no, banyak kan? Ni careless mistake kan? Betul tak? Itu dia betul. Transfer this square, so you have 2 here, so 4 they half lah. Betul? So semua agree?
Yes.
Thank you very much Irfan. Bonus mark insyaAllah.
Alhamdulillah.
Even though you got this wrong je, tak adalah. Apa yang dah jawab lah. So yang ni alternatif lah panjang sikit tapi tak apa. Bla 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 bla. So jawapan dia lah half. Okay. So first you know that the between resistance and the length as well area is like this. To the length inversely proportional area R equals to rho L over A. And then R, when you substitute, it should be not equal to lah, macam yang Irfan sebut tadi tu, it must be actually inversely proportional to D squared. So, assuming this, pi dia tertinggal lah kat dalam working ni kan. So, the first one is going to be 4L1 over D1 squared, sama. And then R2, you substitute the values L2 and D2, so you get half of the original one. So, the answer is B. Okay, thank you very much, Irfan. Tanya. Okay, proceed question 9. The graph shows the variation of the resistance of thermistor with temperature. So which conclusion can be made directly from the graph? Conclusion directly made from the graph, even though you do not know whether it is a thermistor or a filament lamp, itu boleh tolak ke tepi. Yang penting you tahu kalau resistance and temperature, yang ni automatically you akan tahu lah kan. With increased temperature, you have the resistance going down. So, the resistance of the thermistor increases when the current through it increases. Is this true or not? Kita tak tahu pasal current lah kan. Thermistor increases potential difference. No, this is not a current or potential difference between graph. It is a temperature.
Yes.
So, dia kata the resistance of the thermistor increases when the temperature of the thermistor decreases. So this is like a bonus question lah kan. Maknanya apa? Is between C and D lah kan. So kata kalau the temperature of the thermistor increases, the resistor must be decreased because the trend kan. So dia kata kalau temperature of the thermistor decreases, that means it's this region. So the resistance is going higher. So the answer is C. Okay. So this is the operation of a thermistor. Hopefully you guys don't confuse it with the normal filament lamp as we usually perceive lah kan. We usually perceive that kalau increase in temperature dia akan increase in resistance, betul tak? Tapi kalau ni dia punya operation principle is different. It's actually opposite. When you increase the temperature, the resistance will decrease somehow because of the structure within the thermistor. You don't have to go too in depth on that. Okay? You just have to know the operating principle between a thermistor and a filament lamp is actually opposite between each other. Alright? Question 10. A student has a metallic conductor and a semiconductor. The temperature of two materials is raised. Which line in the table correctly shows change in their resistance? How do you answer this?
C.
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 Jawapan soalan 10. Okay. B, C, O, D.
C.
Okay. Sila jawab. Acik juga kan, because you can see other people's main response kan.
No, sir.
Tak boleh Okay. Okay, alright. Okay, we still got 6 more people. 5 more people. 4. Jadi yang keluar masuk kan. Ada yang tiba-tiba masuk kan. Nak kena jawab apa ni? Kena jawab soalan nombor 10. So when the temperature is increased, what happens to the resistance? That means what happens to the graph? Sama ada dia punya gradient increase ataupun gradient dia decrease. So, kan bila gradient decrease or increase, dia punya resistance is the inverse of the gradient lah kan. So can most of you answered C. Can anyone explain to the class why is it C? Why did you answer C? Thank you very much for those who have managed to answer. Anyone? Anybody? So basically, when optical material or a metallic conductor, which is obeying the Ohm's law, when you increase the temperature, what happens to the resistance? It will increase. So it will act similar, but for a semiconductor, it is actually the other way around. Why is that so? Because for a semiconductor, dia akan ada dia punya region between the conductor, in between the diodes kan. So that's where the region in which the electrons travel. So although because when the temperature is will be an excitement of electrons yang menyebabkan indirectly dia punya resistance tu akan decrease due to the increase in current, the current flow. It is as simple as that sebenarnya. Okay, anyhow, we can discuss further on this question later. We proceed first. For the subjective question. The graph shows the IV characteristics of a filament lamp. Does the lamp obey Ohm's law? Yes or no?
No. No.
Why?
Directly proportional.
It's not directly proportional to the. It has nothing to do with the resistance because you will comment on the resistance later. Basically, no, it does not because it is not proportional. Given that the temperature is constant lah kan. Dan kita tahu kalau filament lamp ni main constant lah. So calculate the resistance of the lamp at 4.0. You need to so how do you just point the value of the current of this lamp at is actually equals to 60 milliamperes. Then you substitute into the equations, you get roughly 67 ohms. Kenapa 67 ohms? Sebab kita ambil two significant figures lah, because it is 450 ohm. Okay?
Okay.
Alright. Describe how the resistance of the lamp depends on the current. So kat sini lah yang kita tahu kan, walaupun slope ataupun gradient itu is decreasing, because we know that resistance is inversely proportional to the gradient. That's why the gradient,
The current.
the resistance increases as the current increases.
Okay.
I increase, R increase. Tu je lah. You just mention R increase. Tak perlu nak explain detail lah. Dia punya graph, dia punya gradient to decrease, and we know gradient is inverse of the resistance. Just keep it short lah. Okay. Keep it concise lah. It's not short. It's matter of being concise. InsyaAllah. Question 12. The negative temperature coefficient NTC. Okay, this is your thermistor lah. The disconnecting leads are coated with a high resistivity plastic input. The transistor is in a beaker containing hot water. The temperature of the water is kept constant at 80 degrees Celsius. The IV characteristic of the thermistor is shown below. Apparently, it is linear. For some reason, ini eksperimen punya environment lah kan. So, calculate the resistance of the thermistor. We know the resistance kat sini ialah 1 over gradient ataupun V over I lah kan. Kan? So you can take any point sama ada sama ataupun 20 and you divide it lah. Okay, so the answer 150 ohms. So question B. State and explain the change, if any, to the shape of the graph I is V when the temperature is lowered and maintained at 30 degrees Celsius. So, you know, this is a thermistor. Temperature increase, resistance akan decrease. Tapi kalau kat sini, temperature is lowered. Akan jadi lagi sejuk sebab air kan. Maintain. So what happens to the resistance? The resistance will increase. Lagi-lagi di NTC. Kena take note thermistor ni ada dua jenis. Satu yang kita guna ni lah NTC. The other one is the PTC. Kalau PTC ni dia act sama macam kalau means it is the standard convention yang kita tahu, temperature increase resistance. NTC is opposite. Okay? So what happens is, because we know resistance will increase, so the graph of I against V will be less steep atau smaller gradient. So kalau smaller gradient, macam mana rasa-rasanya dia punya shape of the graph? Can anyone draw? Tajak ni lah, Syirhan. In my school. Ini senang saja, tak perlu nak ni kan, so you can just draw. Okay, silakan. Draw the graph. When the
New graph.
Boleh ke? You can actually draw it kat bawah tu. Dia punya gradient. Draw it here.
Oh, okay.
Just one straight line. That's a comparison. Alright, thank you very much. That's good. Thank you very much. So that is the answer lah. Okay. Although dia tak suruh kita draw kan, dia just suruh kita state and explain why. Yang kita tahu what happens to the shape of the graph, it'll get smaller gradient. Why? Because of explanation, because temperature decrease, resistance increase, and resistance is the inverse of the gradient. Okay. Question 13, wire is made of material of resistivity rho. Write an equation for the resistance R of wire of length L and length T. Given the formula for resistance of a wire S equals to A, so R equals to L divided by pi R squared, with assuming that the wire is a shape ataupun the cross section is a circle, so it's going to be pi R squared. Substitute R equals to 2/2, so you get 4 pi L divided by 4 rho L divided by pi. No figures, no numbers included here, just the formula, just to know how to derive. Okay? Kalau tak terkejut, apa nak kena buat? Okay. Like I mentioned last week. Now, manganin wire of radius 0.15 millimeters has a resistance of 5.33 ohms. length. Calculate the resistivity of manganese. So using the formula yang kita dah tahu, bla bla bla, substitute masuk, pi r squared. So L dekat sini adalah 1 meter. Kenapa L kat sini adalah 1 meter?
Dia kata per
Per
meter.
meter.
Per meter of length.
Sebab dia kata 5.33 ohms per meter of length. So it is a unit resistance unit resistance per length. 1 meter it has 5.33 ohms. So kita ambil ratio tu, masukkan dalam tu. Masukkan kat dalam ni 5.33 divide by 1. So the answer is 3.77. Round it off to the nearest two significant figures. Sebab dia ada 2 ataupun 3. So kita ambil 3 pun boleh. So the answer is 3.8 times 10 to the power of minus 7 ohms meter. With the correct unit, with the correct value, you'll get the full marks, inshallah. Okay. Question B. Explain how your answer in A would change if the manganese wire had twice the radius. So there will be no change in the value of resistivity. Kalau siapa yang tengok dia punya formula nampak macam kalau dia punya R dia increase, nanti dia punya rho akan jadi apa? No, you are not thinking the right way, because each material has its own fixed resistivity value. Okay? So there will be no change if the wire had passed the radius or and you can recall the question that Irfan attempted online yang tadi tu, yang mana dia kata, when I ask, okay, how do you know that the resistivities are the same? Because they are using two similar types of wire. So when there are no changes in the characteristics in terms of the material used, so they will maintain, even though they have different dimensions. Okay? The type of material will determine the value of the resistivity, not the dimensions. So kita cakap the type of material tu, it includes the structure and temperature, structure within the component itself, as well as the how it reacts with temperature. Okay. So just to show you, just to have a feel, kalau kita tengok kat sini, this is a list of materials with its respective resistivity in ohm meter. So you got silver, yang paling rendah lah kan, resistivity dia. Maksud resistivity ni apa dia resistivity? So it will be a good conductor lah kan. So kalau you have a hard rubber, tengoklah dia punya resistivity is 10 to the power of 15. So the resistance dia akan jadi high kat situ. Iron, platinum, lead, all this metal, all itu semualah, they have different types of resistivity. Okay, habis question number 14.
Yay.
Yeah.
Any questions?
No.
No.
So kalau tengok you punya ni kan, wish macam-macam kan. Question 9 semua dapat cemerlang, question 10 ni ada macam-macam lah. So this is actually what I have to face every time you answer your quiz tau. Dia punya kalau dia objektif memang senang lah. Kalau dia MCQ tu, I don't have to do anything tau, sebab dia automated. Tapi kalau subjektif tu, Masya Allah kan. Kalau saya beri contoh kan, give a question. The subjective question starts with 11A kan. I have to read lah all the answers. Betul salah, betul salah, betul salah, betul salah, betul salah. Oh, tengok. This is Google. And now they're migrating to
Soft Teams.
Office pula Okay, so overall kalau ikut dia punya MCQ saja, yang paling rendah dapat 7 marks, which is quite impressive jugalah kan. So highest memang ramai juga yang dapat full mark. All 10 questions ada juga. Okay, so the median is 9. So 9 tu agak impressive lah untuk MCQ kan. 27 is the total point. Tapi sebab yang currently mark ialah hanya yang MCQ saja. Alright. So congratulations lah.
Yay, Alhamdulillah.
Alhamdulillah.
Okay. So if there are no questions before we end, I'll just give you one brief short reminder using the bonus slide insyaAllah. Alhamdulillah. Thank you for very much for those who attended my special session last Saturday morning. Really appreciate it. Alhamdulillah. So hopefully we can have further discussions on it. So for today, inshallah, I'll just share with you a very short hadith regarding something to do with potential difference that probably we can relate with our lives, inshallah. So we know that the definition of a potential difference, or we call it a voltage or a battery, what is it? It is actually the potential difference between what? Between 2 points in a circuit that measures the electrical energy. So each column charge. So you charge tu, each column of charge, each charge tu, bila dia bergerak tu, dia akan hasilkan electrical energy. So the standard units, it is in volt. So benda ni apa? Benda ni, this is in your notes lah kan? So the formula for V equals to W over Q, which is W, the work energy transfer atau work done in joules, is equals to VQ. So this is the first formal definition. The second formal definition is electrical power dissipated per unit current, which is P equals to VI. Ataupun kita panggil rate of change of power is time. Rate of change against time dia kata kat sini kan. So V equals to W over T over Q over T kat sini. Dia main kat sini lah. Because power is equals to rate of change in work and current is equals to rate of change in Q. So sebab tu rate of change of power against current time. Adalah dia punya formula, you know. So these potential differences are used in order to power up the entire circuit. Without any potential difference ataupun voltages, the circuit will not flow any current. So given plenty of resistance pun dia tak akan berjalan. Dia tak akan jadi apa-apa, betul tak? So that is why we have this potential difference that could actually move all the charges, all the electrons, all the holes in order for the circuit to actually function. And if you have any electrical appliances connected along the circuit, it will light up. So kalau you ada lamp ataupun you ada apa-apa lah electrical appliance yang tadi siapa? Fatihah kan? I got your name right kan? Itu salah. Yang tanya tadi kan? Dia akan function lah kan? Alright. So now, there is a hadith by Nabi SAW narrated by Abu Hurairah radhiyallahu anhu. It says here, An-Nabi SAW qala, An-nasu ma'adim, khairuhum fil jahiliyah, khairuhum fil Islam, idha faquhu. I'm not sure, probably some of you have already heard this. If you actually heard this hadith before, please tell me. Okay, please tell me, PM me, sangat-sangat nak tahu. Where do you heard this hadith from? If not, then it's okay. So it says that our Prophet ﷺ, he said, humans, dia kata, anas are like ma'adin. Ma'adin in Arabic is translated as steel, ataupun steel is actually a compound kan, ataupun a metal tau. So humans are like metal, and the best of them in ignorance in Jahiliyyah, and the best of them are in submission or in Islam, provided that they understand. So this was reported by Muslim. So mankind are metals, best of them in ignorance, best of them in Islam, which is referring to submission, when they understand. Nak cerita kat sini, each and every one of us have our own potential, and each and every one of us with specific potential will have specific resistivity. Betul tak kalau kita tengok the previous slide kan? So we have our own respective resistivity to any resistance that I mentioned last week. So kita tengok sini, our potential difference, if it is not channeled to the correct path, then functionkan lita tu, dia akan functionkan that circuit with that very spoiled purpose. Contohnya kalau lah dia punya lita tu ialah untuk nak blow up an atomic bomb, taklah atomic bomb kan, a time bomb lah kan, contohnya kan, to blow up a building. So that would not be put in good use, your potential kat situ. Tapi if your potential is put into good use, then you can use it to heat up water, and you can proceed ataupun you can function your refrigerator and whatnot. So we human beings, mankind, ada potential. sama seperti metal. We conduct electricity. Memang literally memang kita conduct electricity pula kan. Tapi nak ceritanya, kita memang akan ada kita punya potensi. Ya, potential is potensi lah kan. Lebih-lebih lagi you guys yang memang dah terpilih di dalam Young Talent Program kan, contohnya semua pakat nak pergi overseas. Selalunya the typical punya scenario, those who study overseas kira macam paling gempat SPM, cream of the crop. Walaupun sebenarnya you guys tak di-comparekan SPM kan, you guys IGCSE, lepas tu technically tak compare dengan SPP. Tapi pasal dia dah masuk dalam MRSM, dah power dah kan dulu kan. Tak semua orang dapat masuk dalam MRSM kan, betul tak? Lepas tu daripada MRSM, yang MRSM dash middle, tak semua yang daripada MRSM tu terpilih untuk nak pergi ke overseas kan, betul tak? Walaupun ramai orang yang mungkin apply doing, tapi akan ada saringan kan. Because that is our nature kan. Metals are not created just like that, betul tak? They have to go a very tiring process in order to get the end product. Lagi-lagi kalau metal tu is very precious, such as diamond or gold ataupun silver. So those are precious materials that have contohnya low resistivity to conduct electricity, contohnya diamond and whatnot. So those materials have gone through a very tiring process in order to obtain the end product of it. So now this potential, we have to ask ourselves, are we going to channel it? Because we can either channel it into two conditions. Either you channel it into Jahiliyah, which is ignorance, or you channel it into Islam. And what determines that we can actually channel it between Jahiliyah and between Islam is actually our understanding. Our understanding, that means our current, we have direction. We know where we want to go. If we know where we want to go, then we can actually channel our potential to the right place. But if we do not know where we want to go, then we are scared. If kan, you channel your potential not to the right place. Contohnya kan, you've got programmers. Programmers, they build websites, contoh kan. That is type of talent lah kan. So programmers yang build website, contohnya untuk education, preschool, untuk diorang nak buat belajar during this PKP period, that is an example of putting your talent ataupun your potential in good use. Tapi ada juga the other side, those programmers that go down into the dark web and play around with all this pornography, pedophilic punya issues, gambar, video, buat all those fake news. That is an example of putting your talent not in the correct place, or we call it in ignorance ataupun in jahiliyah. So we are always being brought with two options. It's either the path of Islam or the path of Jahiliyah. It's either the path of submission, where at the end of the day, when you submit to Allah subhanahu wa ta'ala, you will get paradise at the end. But if you submit in the wrong sense to Jahiliyah, to ignorance, then you'll end up in the hellfire. There's no right in the middle path in this sense. So right now, my sermon lah kan, my call to you is we have to really make sure that we understand, so that we could channel our potential to the right place, not to the wrong place. Cuma problem dalam hadis ni, dia tak bagi tahu. Kita tahu lah dia punya catch is we have our potential. Now it's a matter of understanding. Problem is, what are we supposed to understand? What are we supposed to understand so that we can ensure that our potential yang banyak kat sini, the potential that I am witnessing today, all these very bright young minds, kan, very talented people in front of me, who can actually comprehend any subject matter in a short matter of time, the future engineers, mashallah. These talents are channeled to Islam, to the correct path. What type of understanding is required from all of you? So, for another day, insyaAllah, I will probably explain. Kita what are we supposed to understand in order to ensure that our potentials are channeled to the correct path and not to succumb to the whims and desires of the ignorance or jahiliyyah, inshallah. Wallahu a'lam bishawab. So I hope that that short reminder would leave you some thoughts, inshallah. So that's it for chapter 11. We will be proceeding with chapter 12, if I'm not mistaken, tomorrow. So starting tomorrow, you can look in your classroom and check out materials and as well as the feedback notes. So this would be your last chapter before the AS syllabus is finished. Although once this chapter is finished, straight away we will be going to chapter 13. Which is your A2 syllabus lah. Sebenarnya yang ni pun kita dah start dengan A2 syllabus kan. So kita akan start terus A2 chapter 13 which is on nuclear physics. Okay. My PhD punya research punya area jugalah sebenarnya. Tapi tengoklah. And then I think that will be the last week before your actual revision. Untuk revision week, break nanti. Sekarang pun macam technically tengah break kan, tapi learning from home. And then after that we'll have your first semester exams lah. Okay. Wallahu a'lam. Guys, that's it. So hopefully you guys boleh maintain working from home, studying from home. Keep yourself sane. Maknanya jangan stress out. Don't be too stressed out. Read the Quran more to understand more, insyaAllah, because we are in the month of Ramadan. 13th Ramadan maknanya kita dah masuk the second nak kata second half belum lagi kan, tapi the 2/3 lah kan, the 2/3 insyaAllah. Okay. Wallahualam. So kita macam mana? Class rep?
Class rep.
Are you here?
Class rep.
Are you here? Nak buat apa? Nak tutup majlis. Tak ada, insyaAllah. I'll close the session insyaAllah dengan tasbih al-Fatihah dan surah al-As. Bismillahirrahmanirrahim. Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Wal asri innal insana lafi khusrin illa alladhina amanu wa amilus solihati wa tawassaw bil haqq wa tawassaw bis sabr. Alhamdulillahirabbil alamin. So kalau sikit ada video boleh buka sebab saya nak ambil gambar. I'll count to the count of 3. 1, 2, 3. Thank you Shirhan for supporting me. Naufal pun ada. Oh banyak je sebenarnya. Okay. Thank you for giving me support. Alhamdulillah. I'm not talking on my own. Alhamdulillah. Okay. So smile. Ya, siap. Okay. Naufal gelap sikit. Awak sebenarnya kat mana? Bilik mana? Okay, insyaAllah. Okay, see you guys. Assalamualaikum.
Salam. Bisa.
Thank you, sir.
Sir.